Greetings, everyone, and welcome back to Microsoft's Java for Beginners series. My name is Brian Benz, and I'm a cloud advocate at Microsoft. I'm joined by Kirk Pepperdine, who's going to tell us a little bit about arrays. Kirk, do you want to introduce yourself and what you'll be talking about?
Hi, Brian. Thanks for having me here. I'm a principal engineer in the Java engineering group. We're responsible for building the Microsoft version of OpenJDK. And I'm going to be talking about arrays. And an array is a variable that stores multiple values of a single primitive type. And each of these values can be accessed by specifying the array name and some index that acts as an offset. And arrays have special language support in Java. So we'll just take a run through arrays because they become an important topic for future conversations. Java comes with library support for the abstract concepts of list, sets, and maps. Most of these abstractions are built on top of an array. In Java, support for array is built into the language. As is the case with most other languages, arrays are used to store collections of primitive data types. Let's see how arrays work in Java with this small example. I'm going to start by declaring an int array. We'll give it a name, array, and I'm going to put the declaration part here, or the construction part of the declaration here. I need to give it a size. In this case, we'll give it 4. And I'll end the statement like this. Now, if we look at the statement, we can see that I have int array on both sides of the equal. And I don't really need it here because I can use this var keyword, which is introduced in JDK 14. And this will tell a compiler, infer the type of the variable array. One of the common things that I want to do with an array is I want to figure out how many elements are in the array, or what is the size of the array. So let's put in a little piece of code here to show how to discover that. So I'm just going to put in a array.length. Let's just put a little label in here to help us recall what we're printing out here. And now we can run this piece of code here. And you can see we have length 4, which is as expected. The other thing that we're going to commonly do is we're going to initialize values, and then we're going to access values in the array. So let's take a look at this particular topic. So I'm going to start with array again, and I'm going to say at index 0, let's put in a value here. So I'm going to put in value 5. Now, let's print out the value. And as you can imagine, when we print out the value at 0, we're more than likely going to get a 5. The question is, what happens if we print out the value 1? Because we haven't initialized that. What happens if we print out the value of 4? Because that's outside of the bounds of the array. The array is going to be indexed 0, 1, 2, and 3 in this case. So 4 is out of bounds. So let's run this code and see what happens. And you can see we have length 4. We have the value 5. We have 0, and we're getting 0 because the array is going to be zeroed out before it's given to us. So we're just going to get that default value in this case, or this accidental value, I would say. And for the last statement, we're going to get this array index out of bounds exception being thrown. So that means that every time we go beyond the bounds of the array, we're going to throw an exception. We're not going to be able to access that. So that prevents buffer overruns from happening. Now, int is but one of the primitive types. So let's see what happens when we change the primitive type here from an int to a char. So here's a char. And you might know that this assignment still works. And you're thinking like, okay, well, that's an int, and it's going into a char variable. What happens here? Well, technically what we would have to do is cast it. Whoops. Okay, that will give us a predictable result. That says go through the machinery that makes sure that this int gets transformed into the char properly. So whenever we're going from one primitive type to another primitive type, we should cast. if you don't cast, then the results you get will technically be unpredictable. In this case, I'm just going to say, well, let's put the char 5 in here and we'll run with that. And as you can see, we can get the expected results, except for we get a funny character, and that's because the 0 gets interpreted as an ASCII character that's unprintable, and that's just how it shows up on the screen. Okay, let's try a different type. Let's try double. And again, this is where it gets really weird, because you're saying, like, wait a second, I'm assigning a char to a double, and yeah, that's perfectly legal, but again, you're going to get strange results. So let's just not do that. I'm not even going to bother casting it, because, you know, we can do it, but, you know, it's not really going to make much sense. So let's just go this way. Just putting in a 2.00D, we're going to run it. And again, length is 4, value, as we expected, is 2.0, and we have the 0 being interpreted as 0.0, and the exception being thrown. I'm going to get rid of this exception here, since we know it's always being thrown. We don't need to deal with that anymore, but let's go and explore string. Now you might be saying, like, wait a second, string is an object, and you said this array thing was only for primitives, and you'd be correct in both statements. String isn't an object, and array only holds primitive value types. But with every object comes what's known as an L value, and the L value is translated into a primitive data type known as a reference. And with that, we can have arrays of objects, because all we're going to hold on to is this reference primitive. Now you can see that this assignment absolutely doesn't work, because, you know, this makes absolutely no sense. There's no way we can convert a double or even an int, for that matter, into an L type, because, you know, at this point we're under the hood, we're dealing with pointers, so, you know, this would really not be a good thing to have to be able to do, because that would allow us to hack into arbitrary sections of memory, which we want to prevent. So I'm going to just put this value into the array like this, and then I'm going to run it again. And you can see that we have length 4. Our text value is there, as we expect. And in this case, the 0 is going to be interpreted as null. Let's switch this back to int. And what I'm going to do here, I'll make it 5 again. And what I'm going to do here is I'm going to say this is a new int of length 4. Oh, actually, let's get rid of this assignment altogether, because what we're going to do is we're going to initialize this array using this initialization notation. And this works for primitive types, and it also works for string. So in this case, I'm going to say 4, 3, 2, 1. Let's get rid of the size, because it's going to figure out the size based on the number of elements between the square braces here. Okay, so when I run this, what you're going to see is that we have length 4. The value at index 0 is 4. The value at index 1 is 3. Now, there's some other things that we can do here that we might want to consider. For instance, we can use this helper class called arrays. It's like a utility class for array operations. And you can see here are all the array operations that are available to us. So there's quite a few. I'm not going to list them all here, but you can explore them. I'm going to go over the toString, and then I'm going to put in our variable in there. Okay, so now I'm just going to run this. And you can see we get a nice string representation of our array. Now what I'm going to do is I'm going to use another utility method here to sort the values. This is a destructive operation, and I'll show you what I mean by destructive operation right here, because I'm just going to take this arrays.toString it again and put in array. And if we run this, the thing to note is that I'm printing the same array, but you can see that the arrangement of the values is different. It's been sorted. And so the original ordering has not been preserved by this method. So that makes it destructive. Finally, I'd like to look at two-dimensional arrays. So in this case, I'm going to introduce a second dimension by adding this set of braces. And now we need to correct our initialization code. If we're going to use initialization code, then it needs to reflect, whoops, the dimensionality of the declaration. And so now we have a 2x4 matrix here of int array. These array2 methods, two-string method, is intended for a single dimensional array, not a multi-dimensional array. So what I need to do is I need to dereference the array so that I only get one dimension at a time. So I'm going to do this by saying for int index equals 0. Index is going to be less than the array dot length. And then we're going to go index, plus, right? And so in this case, we're going to put in an array at index. So it's going to get the row at a particular index. And oops, we need an open bracket here so the closed bracket will work properly. There we go. And then we're going to sort the array at the index. And now what I'm going to do is I'm going to reprint the array at index. So that's going to be our sorted version. And here I'm going to access individual elements for each row. I'm going to access the 0 and 1 element for each row. Okay, we missed on the braces there, so we'll fix that. Okay, there we go. And now we can run this. And we can see we have length 2, because it's the number of, it's a 2x4, so the first dimension is 2. And for the first row, it was 4, 3, 2. We sort, we get 1, 2, 3, 4. And of course, these are the associated elements in the array. And we do the same for the second row. So it's 8, 7, 6, 5 to 5, 6, 7, 8. We end up with 5 and 6 at the 0 and 1 index on that particular row. And that covers most of what you need to know about arrays.
Thanks, Kirk. That was great. Please check out the rest of the topics in Microsoft's Java for Beginners series.
Thank you, Brian.